Hey guys, so this is my final project submission for my robotics digital fabrication project in 2013. First I'll kind of step through how I fabricated the pieces and created them, and then I'll step through the robotics that actually control the movements and the readings. Okay, so you've got two essential elements. You've got this box on the bottom. This was designed by me and laser cut at the University of Houston. And then you have my little robot guy on top, and he's made up of several pieces that just fit together with a tight fit and friction. In most cases, there are a couple where I had to actually use a little bit of super glue just to avoid any disasters and any sort of tolerance issues in the printing. So he's made up of a few parts. You've got the legs. The legs are hollow, and they snap into the bottom of his body down here. All of the wiring and circuitry for the entire project come up from the box through his legs and into either the lights or his head or the pressure sensor. And we'll get into that a little later. His body is all one piece, so you've got this and this arm, which doesn't actually do anything. It just actually makes him, look humanoid because he's got two arms. The top is one piece, and it again just holds in with a tight fit and friction. And then the head is its own dedicated piece. So then you step over to the arm. There is a hole in this side of his body that you can't see because it's covered up by the arm. The pressure sensor comes through there, and the arm is hollow, and then fits into the hand. And the hand was actually designed with the pressure sensor in mind, so it fits perfectly in there. It doesn't require any glue or anything. And then this cover that covers up the pressure sensor. Okay, so then I've got the box, and the box is just a real simple laser cut. The top is free, so if I need to work on the piece, I can take it off, but I don't have to. The bottom is held together with glue, so it doesn't just fall apart by riding in the car or something like that. And there's a hole in the back that my wires come out. So we'll start with the wires to talk about the robotics. So one of the wires powers my Arduino unit. That's the microcontroller that we used to run everything. And the other powers my servo, because in this project I decided to use a 360 servo to control the movement of the head, so that I could have it spin around at a certain point. But that servo takes too much power. I can't run it just off the 5 volts the Arduino has, because as any of y'all that have done robotics work before know, when you run out of power, things start freaking out, and the servo just was not getting enough power. So we run it off a dedicated 5 volts constant from the USB on my computer. So inside the box, you've got a 6-inch breadboard over on this side. In the back, you've got my Arduino unit, and then right in the center of the box, you have my 360 servo. Now that servo, on the spindle of it, is one end of what's honestly just your everyday soda straw, and it runs up through the body to just a little peg that's on the bottom of the head. So those were planned, and they fit together perfectly. And the only reason I did it that way is because the straw is totally smooth, whereas 3D printing can be a little rough, and I didn't want any chance of anything getting wrapped around or tangled up on the inside once I had set it up. Now, you've got also this range of LEDs, and the way the project works is there's a pressure sensor here in the hand, and the coding is set up with a set of switch case statements. So in essence, what that turns into is I push the pressure sensor, it reads it, and it says what range is that pressure in. And there are 10 different levels, 10 different LEDs, and based on whatever range it's in, it lights up the corresponding LEDs, like a gauge, if you will, and it has the servo respond in a particular way. So in this case, what I was kind of reaching for is when you have that friend that just shakes your hand too freaking hard, and every time you meet that person, you know he's going to do it, and it's just kind of, especially if you're a skinny dude like I am, you know, it's kind of a pain in the butt. So here's the deal. You shake his hand, right? And the lights start lighting up, and his head starts to shake. Like, no, don't shake my hand so hard. No. And so the pressure sensor is not the greatest tool. Occasionally it'll skip a pressure range even if you're trying to squeeze really gently. But it's pretty good. So you just squeeze, and when you finally get to that last pressure range, the 360 servo let me spin his head around kind of the Exorcist style, if you will. But that's it, guys. So that's my box, my robot, and the way Arduino controls it. Hope you enjoyed.